this chapter, so that we mentioned why, so that the okay, so anyway, let me quickly go through what we have learned last time. Basically, we are trying to talk about this new chapter about the building system, right? And then the building system, of course, consists of with multiple subsystem, including mechanical, you need a mechanical structure, right? And water system, now HVAC, heating, ventilation, and cooling, electricity, lighting, fire protection, and elevator. So that of course, one of the most important this kind of structure is what? Most important actually is mechanical design. If you somehow fail your mechanical design, and then the big problem. So this is one of the most important is a mechanical structure design, right? And then the other is play the supporting role for all the building. So I just let you know that you before we go into much deeper, so at least you have some basic understanding about this issue, okay? And of course, we also mentioned about the issue, right? So that every building actually all the mechanical structure member, and show you last time we have what? Every building we can decompose into what? Simpler mechanical structure member, right? For this building or any kind of building, so that I can draw some simple thing. What do you think? How can we try to think about this building as how we build this kind of structure? Well, basically, you need to think about how we can, for example, we can think about some column, and then for sure you build some one-dimensional this kind of a column, right? And then you have additional maybe the beam. Sometimes we have some special name in our mechanics. Some mechanic is this called a beam, right? There's some special structure member here, so that we most likely we have some special name, right? For this this kind of structure member. So this is a column, right? And of course, sometimes we have additional two-dimensional plate in a two-dimensional plate. Here I'll show you. Okay. So this we can, in our solid mechanics, we can call this two-dimensional structure member plate, right? So that once you have this thing, and then of course many times we have additional this kind of partition and additional this kind of beam, right, to support this kind of each floor. Do you understand? So that I just tell you, actually, although the building can be very complicated, right? So it can decompose into several this kind of one-dimensional structure member or two-dimensional structure member, and then to construct this building. So that this is something is easy for you. Of course, we also mentioned that you may want to think about how to make this kind of building structure using the online CAD program. So that last time we mentioned what kind of CAD program you can use. Actually, there's a couple of CAD program. Now, before, as I mentioned, when I was student, and then many of this kind of commercial CAD program for mechanical design is not free. You have to buy. But now you are lucky in this kind of new world, right? You can enjoy many kind of free this kind of software, or free this kind of online this kind of cloud computing platform. Last time I show you, I don't know if you have tried to look into that online this kind of CAD program, ThinkScale, right? Of course, there's another one called the Tinkercad. Actually, I think Tinkercad is another quite interesting like online software, like a CAD program. You can design three-dimensional structure. Now, for the different kind of engineering project, or even for some maybe from this artists seeing people make some 3-dimensional structure for fun. As I mentioned, there's a large number of these kind of motivation to build some virtual world, right? Virtual building, NFT, so that you may want to think about this here, right? Actually, you can register for this kind of free account Tinkercad, so that it's online this kind of platform, and then you can build a building by yourself, easily. Do you understand? So now all of you can be a engineer at least use this kind of free online CAD program. Do you know who make this, who designed this kind of house, 2-floor? You're surprised. I just show you this is not done by me. Who? Any idea? Who make this kind of design? It's 10 years old. You know who actually designed this model? So that it's one student mentioned farming actually make a good thing. Actually, it's my daughter, 10 years old. You think a cat can design this kind of structure, so that now you are now student in university, so that can you make it even better design, so that of course the good thing of this online, this kind of CAD program is you can easily find those kind of design people share on this kind of online CAD program. That's I think it's a powerful way you can learn about this thing. Do you say? That means if you try to search about typical building, you see, building maybe some kind of special building, and then design, and you can find. I'm pretty sure you can find this kind of different kind of example, and then try to think, oh, I can try to learn about this kind of as an engineer, right? So before you can make your own design, I can see it's important you can learn from the other people design. Do you understand? So this is something, this kind of free online CAD program, I would say is something quite important, useful for all of you to quickly get some sense, right? Before you go into much deeper about more detailed structural design of building, or maybe HVAC, right? Heating ventilations, and that why not you can easily use the kind of cloud I think one kind of open source the platform, right, to think about this kind of building engineering. You see, I just key in the keyword, I immediately find that so many people try to come with this building design, and then so that I do encourage you may want to think about, although it's very difficult for our young people to buy a house. Why not you build a virtual and make a building in this kind of a CAD program, online free CAD program, and then think about this issue, right? So that if a good design, maybe some people, someone like your design. Do you understand? So this is actually some idea. So that this Tinkercad originally is I think small start company, and eventually acquired by Autodesk. Autodesk is one of a very big CAD program, this kind of software company, FEN, for building design, mechanical design, so that you can think about. So this kind of online, this kind of platform, not only like Google, Facebook, and Amazon, so that this kind of online platform, right? Online cloud computing platform for this kind of engineering design, I can see is useful and interesting for all of you to think about, to play with this thing, especially for this course. I now, of course, although we cannot make a real building, but at least you can easily make this kind of design on this kind of free online this kind of CAD program. So that so I don't do you have any. I encourage if you're done, at least you try to go this kind of Tinkercad to think about the many other people's design, right? So this is something I would say interesting. And of course, in terms of building, as mentioned last time, so that basically we have classified the building loads, right? In terms of dead load, live load, snow load, white wind, seismic, vibration, and shock load. And as mentioned, shock load was the recent this is something quite important after 911 in United States, right? So that's something is of course also mentioned about this, and we'll also quickly show you about the issue. When we look at the structural design of a building, we mentioned in previous slide. So basically, the member here, member is structural member, right? We mentioned four for different kind of part of the building, right? So that once you have a key thing here we mentioned is we of course we can just simply use Newton's law, right, to study this kind of static, right? Once you apply force, right, in one special structural member of the building, and then we'll understand how big the force. But unfortunately, to study the force is not enough. We need to understand about the failure, how this kind of the building will fail, right? So that the most important thing now is not how the force. The most important is actually some kind of a mechanical strength and also stress. Stress is the way we our engineer, right, in mechanical design in the civil and ME and EE, right? We try to look at these things. So I just emphasize this again. So this stress is a very important concept, right, for our this kind of mechanical design, because again, we just emphasize again, right? Stress basically is what? It's a normalized force, okay? It's a normalized force, right? So that in this case, with respect to the area of most likely the cross section area, right, of this thing for this particular being. So basically, for example, you have this kind of a tensile stress, right? You stress this thing, and then so that in this case, here, we can try to emphasize. Basically, once you have this kind of tensile stress, right, you apply this loading thing. So this is tensile, right? I mean, you provide this kind of stretching of this structural member, and then of course in this case we have to look at this kind of area. This is a okay. So this is the area we try to study, cross-sectional area. Okay, right? Maybe define A. So basic stress sometimes we define as with respect to this, and that means your force divided by area. That is the one we try to think about, normalize this thing. In this case, it would be important for us to look at if this mechanical design of this structural member of the building is okay without any under certain many different loading. With the stress will not too big, will not too cause some smaller, typically smaller some maximum allowable stress, right? Usually we use some symbol, for example, sigma as here, and then we make sure that this sigma stress, right, this demand stress as maybe it's some maximum allowable stress of certain material. Certain material is related to most likely related to some mechanical property like a steel, right? Different mechanical property, right? Different this kind of material, steel, right? RC concrete or wood, the different kind of this sigma maximum about the mechanical strength, right? So this is one of I would say most important concept, right? So that we need to think about in our mechanical design for the building for some maybe mechanic design of maybe table and some even electrical appliance, so that I can see this is one of important thing we all of you. I hope you can really have some basic idea. Of course, if the design no is not good, why and what happened? It going to collapse, huh? Collapse. That's something. Collapse of the building is so critical. People will die. Do you understand? This is something very anything related to building design is non-trivial. If you design a smartphone, it fail, you will not kill people. But if you the design of building fail, people will die. So this is a totally different kind of issue, liability issue. So that when you think about this thing, let me show you about this. Again, this is a typical thing. Why? So typically, I just show you this engineer, right? You see, if you have poor design or design didn't meet this kind of a building code, and then the building may collapse. This is one of a big issue, and then people will die. Unfortunately, still every year we see some building will collapse due to sometimes is poor design, sometimes is poor construction, sometimes it's aging, or sometimes maybe is some additional loading, right? Additional loading due to maybe some external unexpected loading. So that's why let me just show you about that. Remember last time we mentioned about that 911, right? So that 911 is unfortunately it is another some new. Unfortunately, it's a very sad story, right? So that there's I mentioned, right, there's multiple loading for the building. So this 911 actually create a big impact for the building design, and the government of the United States have to change the building code. Do you understand? That's something, unfortunately, is a very sad story. More than 2,000 people die. I still remember about more than 2,000 people die. Let me quickly show this very short video clip to see the importance and the issue, right? So that because 911, so that at least the building code of the United States, they add this kind of a shock law, so that this is something. Hello. So this is again, I just mentioned that it's one of a big problem, right? Unfortunately, is man-made the failure. So that so that before nobody have ever think about the building design have to consider about this kind of shock law. So that so this is something is unfortunately, right? So that engineer have to learn from this kind of failure. This kind of thing, and then try to think about how to deal with this kind of design. Do you understand? So that's something I just tell you because this kind of thing, so that the building code was add one additional this kind of job law. Do you understand? Actually, another thing is this kind of seismic loading and vibration loading also come from some a big issue, collapse of mechanical structure like bridge. So that in like maybe 100 years ago, when people think about the design, the building of those structure, it may be bridge. They just think about the static design, like Newton law, summation of the force equals 0 and things. But of course, we have this kind of dynamic loading, right? This kind of earthquake and even some maybe high-speed train, and some other big loading, right? Or typhoons, these things. So all this one become something quite important thing. Again, so that's why, of course, we just mentioned that for typically when we look at this kind of structural design of the building, again, we most likely we have to think about issue about mechanical design in terms of dimension, right? About how big is this kind of crossing area, right? And the length of your mechanical structural member, and also what kind of material you use. What kind of material you use? Do you say? Yeah, using the steel, soil, plastic, wood, or other thing, right? And then, of course, another issue is we also think about it. If you're using this kind of very brittle material, this something can cause some problem, right? So because this, for example, if you use those kind of concrete actually is a bit more brittle. So that's why for the real building design, we are not only using concrete, right? What do you think? So that typically concrete is a little bit concrete is a little bit brittle. So that's why in practical engineering, we put this kind of reinforced RC, right? RC, reinforced concrete, right? Maybe that means with additional more ductile maybe it can provide this kind of more flexibility, right? Ductile maybe, for example, steel, right? This is a commonly used in many modern building, even in Hong Kong, many big city, right? So that means this something is important, right? So in terms of mechanical design, we need to think about not only how big is the building and all the dimension or thing, but also what kind of material we're going to use. So, and of course, last time we also mentioned about once you have a good design, right? Your all the stress is okay. Next one is another issue about the buckling issue. That means if you have very long this kind of a tall building, so that even though your mechanical the stress, right, is okay, smaller than maximum level, so that if you have very tall building, right, and then so that then you have to think about this length and this area, right? So this area, the length of the building, if this kind of aspiration length of divided by area is not good design, and then they can cause some buckling. Okay, but I also show you last time about this buckling to show the possibility of this kind of failure, so that this classify another family of issue, right? Elastic instability. So that so mechanical engineer also need to think about this one in when you do the design of this building and the mechanical structure. Not only building, maybe bridge and other things. I just tell you, this is a typical issue for this kind of mechanical design. And also was mentioning about the fire resistance is another big issue, right? So that especially nowadays we have so many people stay in this kind of a big building, right? Once you have some fire, so that what's the issue, What's fire? And then if don't have a good this kind of fire engineering, so you may people may easy die, right? So the fire engineering means we have to find some good material, right, for can use in this building structure, and also what additional equipment, right? For example, small detector. If you look at our UST, this kind of the classroom and office, this kind of classroom and the office in our UST, we do have this kind of small detector. Do you understand? So this is something I just tell you, it's a small detector, right? I mean, so that this is something important, right? So that in terms of a real, not only this kind of material issue, small detector, right? Somehow the sensor, okay, to detect the fire or detect some smoke, right? And then of course we have some sprinkler, right? So that I think we USD also have to follow the building code of the government, so that to in case we have real fire, and then so that we did the building well based on small detector or some additional maybe this kind of computer control system, and then we trigger this kind of sprinkler, right, to what, right, make sure that we can try to stop this kind of fire, right? Do you understand? Otherwise, it can be grow and then people will die. So this is something I think quite important thing for every building, right? And of course, sorry. And then another important thing is what this is a flow system, right? So that in reality, right? So that actually for different building, we may use different kind of flow system design. Either you can use this kind of steel, concrete, or wood. I think it really depends on what kind of a building. Right? For commercial very tall building, like in Hong Kong, like with many tall building, 10 floor, 20 floor, or even much higher, 30, 100 floor. And then in this case, when you think about this thing, that means we need to think about we have very good this kind of design of the floor, right? The deck. That means once you have especially a very tall building, right? So that this loading, then you need to think about how we have a good foundation and this kind of flow system to support this kind of load. Okay, so this is something quite important. Wow. So most likely if you have very tall building, like many tall building in Hong Kong, so that we most likely we want to get a much more stronger material, right? The steel, so that make sure that this kind of can now support this kind of very heavy loading, right? But of course, if you have this kind of one floor or two floor, this kind of like a house or something, this is very common in California, United States. So that if you not very tall building and then maybe one or two floor, and then most likely you can just think about using this kind of simple, right? If you one and two floor, this kind of building, and then in this case you may think about try to think using some cheaper material which commonly used in I think North America, like in California. I actually very common in United States. If you don't have this kind of tall building, they may simply use wood, right, for the building. And then in this case, you don't need to use very sophisticated this kind of flow system. Okay, so this is something I would say quite and then next one is we can see we talk about flow and building wall, right? For this kind of modern building we see in our Hong Kong, very common, so that our building wall is not that so simple. We have a much more sophisticated design. Do you know why? Why we have that complicated design? Because in reality, so once you have very complicated building with so many floors, so many office, or even some apartments, so that in this case we have to consider about many issue, right? As I mentioned, the kind of building engineer is system design, right? So that you need that the building wall have to consider about many issue, right? In terms of, for example, you need to think about the this kind of transparency issue, right? To let those kind of some solar radiation to enter, right? This is the thing, and of course, on the other hand, you may also think about additional this kind of internal wall to provide what? Provide maybe electricity, right? So that many times, so every this kind of building, you need to consider about not only the certain window, but also the electricity, maybe also this kind of wire, this kind of internet connection, Ethernet connection, and the many other things. So in this case, it's much more sophisticated, right? And then, so of course, in general, now we think about this another quite important thing, right? For all the most important structure, the skeleton of this kind of a big tall building, so most likely the loading force is very big, so that we have to think about how we're going to think about the what kind of this kind of main this kind of structural skeleton, what kind of material use? Right? A very classical way is using steel, right? Because steel has much stronger mechanical strengths, right? In our solid mechanics, if you go into our this kind of solid mechanics in both in mechanical or aerospace and also civil engineering, we need to think about mechanical strength in terms of what Young's modulus. That's something in this case, most likely steel has much stronger mechanical strengths, right? So in this case, it can build this kind of much tall building. Okay, so that this steel frame building is as I would say classified as still a little bit new, right? In the past 100 years, right? Like maybe 200 years ago, most likely, I think engineer didn't have the skill and experience to design this kind of steel frame, right? So that gradually, of course, now this has become more common, especially we have much more advanced computer, right? And also this kind, I show you this kind of CAD program, FEM, right? Finite element method, or called FEA, finite element analysis system, so that you can try to do much more simple the kind of structural analysis, right? Using those kind of software. In old day, as I mentioned, we have to use this kind of commercial. We have to pay the money, and then nowadays you can probably try to use this kind of free CAD program to think about this kind of mechanical design. Last time we also show you about this thing. I don't know if you have a chance to play with this kind of free CAD program, right? So that again, this is a free program, and then so that again, you may want to look at this kind of structure design, right? And then think about, hey, this is how you can see all these things. And basically, in our lecture note, we just show you about this kind of very simple thing, right? But if you click this kind of source and easily look at what's the typical, right, way, so that engineer, right, in terms of structural design, how we look at this issue, right, to look at their design, so that that is something now is much easier for you to look at this kind of different kind of design in very simple way. Do you understand? So this is something I can see now. All of you has this kind of access this kind of free online this kind of FEM simulation platform, so that I think it's quite interesting. Right, before I can never think about this kind of engineer can easily access this kind of free free this kind of software to do this kind of design. See, the study, wind loading, actually ventilation, mechanical design. So this is a quite interesting way think about this kind of engineering now. Open source, especially all this is open source. That means if you register the car, and then you can look at the other engineered design, right, on this kind of cloud computing platform. And of course, I was mentioned that so in general, there's again different kind of a way to make this kind of a whole building. Steel, of course, is still quite important. Advantage is a high mechanical strength, right? Uniformity, elasticity, performance, ductility, right? That means it can be easily more flexible compared with those kind of concrete. Concrete is more brittle. Once you have applied some loading, it can easily crack. But this kind of ductility, right, is something it's allow you, once you have sudden loading, and then you will not easily have this kind of crack, right? So this is the same thing. Okay, of course, there's no perfect this material, right? If you use steel, then you have some problem, as mentioned 911. Once you have a fire, and then this kind of high temperature may cause some melting of steel, so that it can correct collapse. You say so. This is thing. That's why in reality, so engineer we come with compromise this kind of idea. So we are not only use steel. How we do that? Huh? We do combination. Why? RC, reinforced concrete. Why? We use steel, have high strength, but we try to have additional material. Make sure that a little bit fireproof, right? So that in this case, we use this kind of hybrid design, hybrid material, right? So that's why typical design we call RC, reinforced concrete, right? So reinforced is using steel, right? Reinforced this thing. And then concrete is more, I think it's more fireproof. So do you say this is the way so that we do this kind of hybrid way to overcome this kind of a practical engineering issue. Okay, so that's something I hope you. This is something is quite important, right? And of course, if you're concrete frame, and then that's what you see. Reinforced concrete is here. I told you it's quite common, right? So not 100% steel, right? It's a little bit more compromise solution, so that the add steel bar, right, for tensile strength. As I mentioned, for concrete, if you apply this kind of stress, this thing, and then it can easily crack. But the concrete is good. You have a compressed stress, right? You apply loading, and then it will not easily break. So this is something you see. If you have this kind of saying, like if it is concrete, and then if you apply loading, it is can compress it, and then it's okay. But if you tensile, this is on concrete, it can easily crack. So that's why we think about this kind of reinforced concrete, right? Steel for tensile strength, and concrete much more compressive stress. Okay, so in this case, you have find some balance. Okay, so this is something it's at least give you some idea how we can engineer come with this kind of practical engineering design. And of course, there's another typical new trend is we want to do precast concrete. That in the manufacturing plant, we try to make this precast concrete or precast concrete wall or something, and then do assembly. Assembly in a construction site, so that it can be more efficient, right? So that I think Hong Kong government do encourage this kind of a way to be more efficient for building engineering. So but the name, I think from Hong Kong government point of view, they call modular, modular design, modular this kind of the building design, right? It is for construction. This is something I think the Hong Kong government actually do try to promote this concept, because it can be much more efficient for this thing. Especially in the building, in the building. On the construction side, if you try to do all this thing now from scratch, right, and it may take much longer time. Here I show you one this kind of Hong Kong government, this kind of they promote this kind of modular design. Modular, do you say? This is the Hong Kong government's this kind of building department. So they hope you can see. If you have precast structure, and then you try in the manufacturing, there's special name, MIC, modular integrated construction, right? In the manufacturing plant, and then once you do this one, and then you move, right? Of course, you have used some kind of a truck to move this kind of large, this kind of structure to the construction site, and then do this kind of assembly. So this is, I think, at least Hong Kong government, I think it's much more, I would say, efficient. I would say more efficient to do this kind of building construction. Okay, and of course, there's another issue, right? So there's no free lunch. In this case, modular this kind of construction is okay, but I know that there's certain limitation. What's the limitation? Actually, from the government point of view, if you use this kind of modular way, MIC for building construction, what's the problem? Actually, they still has some limitation. You cannot go to the too tall the building. Otherwise, they may have some problem because there's some certain limitation. There's no perfect this engineering design for this thing, right? So that they still have certain limitation for this kind of MIC. Okay, modular integrated construction, and of course another branch of this kind of we call the wood frame system. So that if for those kind of countryside, one student asked about this. Once from the this kind of Zoom chat with MIC, what is the maximum floor for the building? This is very good question. It depends on the building code. Of a different government. Okay, so that this is very good question from our one student asked this thing. In general, according to what I have seen in because I got this kind of involved with 300 million Hong Kong dollar this kind of project, Hong Kong CRC, right? So that different building code for different government, the different requirement. Okay, so that it really depends. I cannot give you exactly number of floor, but in general, I think the highest floor for with MIC is most likely in Japan. Japan actually pushed this kind of MIC for much more wide because Japan suffer about aging problem. Japan is in the kind of aging society, so that they need to find a way to do more automation, do the kind of in terms of engineering, so that I think the Japan they really continue to improve the kind of MIC so that the highest floor. But in mainland China, I think it's a little bit shorter. Number of floor is but the Hong Kong actually, I told you I can show you. I will try to provide this kind of more information about the building code, right? So it lists in the building code for different government, different region, and different specification. It's something. It's really depends because why it depends on the different country and region. The idea, because for example, Hong Kong, Japan, what's difference? It's a building design. Japan has a lot of earthquake. Hong Kong has no earthquake issue. So that once you have a tall building, then you really have to think about if it's robust design. Of course, there's a weather, of course, weather condition, right? Some country region, some region it has some earthquake, typhoon, some maybe no thing, right? So it's something in general. In general, I think it really depends on the building code. From different country region, different thing. I can see this is something is of course I will provide this kind of information and put on our Canvas website for you to as a reference. Yeah, and of course this another thing is a foundation of the building. Why? Foundation, I mean, before you try to build 1, 2, 3 floor, and then so that we have to try to do this kind of foundation engineering. Is one part of geomechanical engineering, right? So that in this case, foundation is I think critical. Why? So that if you don't have a good the kind of foundation, and then so that and then sometimes you can be great big trouble. So this is something, and then there are different type of way. You see, for example, you see coarse grain, this non-cohesive soil, and fine grain, organic fibrous soil. So actually, it's really, of course, important thing. And then of course, unfortunately, soil and this kind. What's the problem? Huh? What's the problem? Actually, it's very complicated in terms of mechanical property. Depends on, do you have water content, moisture, frost, shifting, and also some other issue, liquefaction. Oh, that's another issue. So that if, for example, if we have a big kind of storm, raining, right? And then so that raining and typhoon, and then in this case, one the big rain, and then what happened? A lot of rain will go into the soil, and then it may change mechanical property of your foundation, so that liquefaction is unfortunately still happen. So that maybe you are too young. So that I remember, in Hong Kong in 1970. I don't know. Maybe you are too young. In 1970, I remember that there's a big trouble about this issue in Hong Kong Island, especially the peak. So that there's some problem about this kind of liquefaction, and then to cause somewhat landslide, and then some building will be collapsed. Will collapse during that, and people will die. So that after this big problem landslide, why? So that once you have big rain, and then a lot of rain going to this foundation, and then so that in this case, you may see this kind of liquefaction, and then so that the building may collapse. So this is unfortunately, this still happen, and then it can cause this kind of building collapse. So this is something unfortunately it still happen, It's happen. Then so that we see, right, this thing. Of course, now we have this kind of global warming. We have a lot more this kind of typhoon, hurricane, and in this case, you can see that this kind of liquefaction may become very common things. Of course, the government may need to think about this issue, right? So that you may think about to do this kind of building, change building code, make sure we have a much better design about foundation. So that is, I may see, I think that it's interesting for you to see some real video about this kind of problem, right? So this is, I think this is something I think important and useful for you to think about this kind of. Look at this. Well, we have online this kind of thing, so that although you cannot do it real experiment, at least you watch this kind of video to see. See, you can see. But we have a lot more this kind of water inside this kind of foundation. A lot water, and then you really cause trouble. You can see. That's why you can see. Oh, this is Japanese foundation. Okay. So that I just tell you, of course, there's a series of a real this kind of collapse of this kind of building collapse due to this kind of slide. So it's still happen, unfortunately. I told you, you see this still happen. Quite common, especially global weather change, and then we'll see this can be still a big problem. And then so that of course that's a real issue, right? So that once you have this kind of much more frequent, this kind of big typhoon, hurricane, and then so that how can we deal with this kind of thing? And I think maybe we need to think what the government may need to change the building code from my point of view. I found if we keep have a big this kind of global weather change, right? So that I think both things maybe the building code is probably need to be revised. Okay, so this become revised accordingly. So do you say otherwise if you use old design, no all the building code, then so that it may not be good enough for this in the near future. So this is something is I would say it can be a very big issue, especially global warming. Okay, so anyway, I just show you the video now, but it is this kind of issue. Unfortunately, I would say we see more and more problem. So for those building, right, the old building, then if the engineer, the government didn't try to study about the risk, right, so that maybe more people will die. Okay, so that is unfortunately this is a real truth. Okay, and anyway, so here I will just show you about the actually foundation has different design, different system, right? Here I show you a series of this kind of in general classified into the deep system, shallow, and then deep system can be used maybe use concrete, tiles, steel, and wood, right? As this kind of thing, and then even concrete was classified different kind of design, on-site, precast, and auger in place, taper, and casing. So this is just give you idea though, so that the building engineering, it can be much more detailed, but at least you give it some rough idea, right? So about thing, and of course, after we make this building down, and then so that then still building is like human. Human, you need to do some kind of a body check and to see any problem, right? So that all the machine, including building, we have to think about do the maintenance, regular maintenance, so that this is something important, right? And because if you don't do the regular maintenance, then this building may cause some problem, can easily degradation, right? So that due to maybe corrosion, right? Abrasion and fatigue, impact, many things, right? So that especially in Hong Kong, what's the issue? Well, Hong Kong actually next to this kind of ocean, right? Sea water, so that this kind of sea water may cause this kind of course, one student, our building now in Hong Kong, we have every year, most likely we have some typhoon, right? And corrosion, seawater actually has certain kind of problem, cause some problem for building. So this kind of thing is, I think it's an important issue, right? So that especially in seawater may cause some corrosion of the building material, right? So this is something real issue. So that that's why typically I think Hong Kong government has certain kind of regulation, right? After certain period of time, and then I think that every building, especially tall building, they have to do some regular this kind of maintenance to check if this building design or any crack or something you need to do some maintenance. I just show you that unfortunately yesterday one professor's office got some failure. I just upload that thing, right? So that even inside the building you see this kind of failure. I just upload the photo about this kind of collapse of this ceiling from one office in our MA office. We happen. I will just to upload that photo for you, and then for you to see. Yesterday we happened one office got some collapse, the ceiling collapse. You cannot imagine. So that this thing, I was surprised. This is a good something real story. So that even the building, our UST, of course, have to make sure that they have do some regular check this kind of problem of the building in terms of mechanical structure. Otherwise, you can see this thing, right? Many cracking, spalling, disintegration, and then yesterday's failure is not this. I think it's the beam. The beam. There's some aluminum beam inside our office. The ceiling, and then somehow they crack. Do you say? So that actually I will upload that picture about yesterday's problem for you to see the real problem. So that let me see if I can anyway. After the course, I will try to upload that picture I just took in Professor Sherry Chan's office about the failure of this kind of ceiling, and then fortunately Professor Chen didn't get any injury. Do you say if you're big, no, very heavy, some fail, or you can people inside the building even die or get the injury. Do you say? So we're lucky. Professor Chen actually didn't have any injury. I think it's something. That's why this kind of failure of the building or failure of even some part of this thing can cause some very big problem. Okay, and then another thing is of course if you have using the material not the stainless steel RC, use wood. Wood also has some issue. Why? It can go some maybe water can cause some problem for the wood. No, wooden this kind of a building. Why insect is another enemy. So that okay. Anyway, so that the in general when we have the different material to use for the building design, so that then we have to think about another issue. Why this is very common now. Why when you think about this kind of new building design, we think about what green building design or smart green building, and then zero carbon emission. Why? So that I show you this become very critical now. So that we need to think about, of course, many issues about this kind of environmental issue. Why? And of course, nowadays, if you want to have a energy efficient building or zero carbon emission building, so that we may need to what leverage some additional energy from the environment. Solar energy, right, is something important. So that if you can use solar energy for lighting, solar energy maybe for power, right? Power some of maybe some kind of electrical appliance, and then so in this case we can reduce energy consumption, right? And then also reduce this kind of CO2 emission and carbon footprint. So I think this will be quite important, right? Of course, there's another issue. Issue is if you have good mechanical design of the building, and then you may also use this kind of natural convection for cooling. You may don't use this kind of forced convection using air conditioning HVAC. So this is another thing we may mention, right? Natural ventilation. That means once you have this kind of solar radiation, what happened? So radiation will what? Will heat up some part of the air inside the building, and then once you have solar radiation, this kind of heating, and then so density of air inside the building may be different, and then you can create this kind of circulation of air, right? So natural ventilation. Okay, so the natural is I think another way we can more think about the green building design and minimize energy consumption. So that this is I think some new building they really try to leverage this kind of natural ventilation, right? so that if a good design of the building, and then you can see first use solar this kind of this radiation to replace the typical lighting like fluorescent lamp, LED, right? And then use this kind of right design. Solar radiation may also induce this kind of additional wind, right? Due to the natural this kind of ventilation. Okay, yeah. So that's something. Of course, we will describe a bit more about this kind of HVAC, right? Heating, ventilation, in following this kind of chapter. And again, so of course, there's another thing, right? So that in general, the building envelope, so that usually, of course, it will try to protect the human from attack from the old things, attack from those kind of animal, right? And then it can block rain, snow, minimizing, heating, and dirt, and other things, right? So that's become very common. And of course, I think one of the big issue now is we have a global warming and global the climate change, and then so how we can really think about the building engineering as I mentioned, right? So that once you have a lot more this kind of typhoon, hurricane, and extreme the weather, sometimes too hot, sometimes too cold, and then so that in this case it's clear it will have impact on the building design. So that this is something I don't think it's only engineer to think about the government, right? The government, this kind of thing, like a building department of Hong Kong and other building, this kind of government agency have to think about this thing to deal with the issue, and then probably change the building code. Okay, and in general, you see, for real building engineering, actually, it can be much more complicated. Why to think about this kind of building design criteria? Why think about first, of course, still, I say most important in the first criteria for building design is your loading. Mechanical loading will not cause the collapse of the building. That's the first thing. Then you look at the other issue, water. There's some leakage problem, air infiltration, also thermal expansion. Once you have this kind of very hot weather, and then hot and cold in the summer, and so that you may have this kind of thermal stress, thermal expansion and contraction, heat transfer, and many other things. So that eventually all these things will typically, I think all the building design have to follow the building code of a different government. This has become quite critical. Okay, and okay, anyway, so here I just show you that in terms of building maintenance, right? So once you have a building, and then so that again, building is like human, right? Human can easily get sick and get some disease, right? So that in this case, a building need to do some maintenance, and then to because we may have a building may suffer some kind of problem, right? So that once it's designed, bad design, and also another thing, if you choose some wrong material, right? Also improper construction, right? If you're good design, and then those kind of construction worker didn't follow this kind of your design, then your problem, and then if you don't have a regular maintenance, and that's also something. I don't know if you see that in general, the lifespan of the building in Hong Kong in general is much longer. If you look at, let's say 7 years ago, there's an article in New York Times mentioned like a typical lifespan of this kind of a building in mainland China is much shorter. Typically, they say about 30 years only. But in general, as a Hong Kong, the building usually I can see most likely can probably 50 years. And that do you have some idea why? What's the difference? Why Hong Kong the building can last longer? Any idea? Why? What is the difference, of the lifespan? Of the building, in Hong Kong and mainland China and other places. One student mentioned is maintenance. I would say is one of quite important, because Hong Kong government have been follow the UK's this kind of the system, right, for the building co-engineering, so that in general, I think Hong Kong has a government has certain kind of regulation, right, so that every period of time, every building had to do some maintenance, and then of course the less earthquake, and so that this has become I think quite important for you to think about the issue. Yeah, but in general, actually 7 years ago, there's one, I think, at this article from published in the New York Times, so that's mentioning about this issue. Why 30 years, I from my point of view, is too short. Invest a lot of this kind of money and the resources by doing that. If it, after every 30 years you have you try to get rid of this building and rebuild again, so it can really create some trouble and generate many kind of garbage and waste, doing that. So this is something quite important. Of course, I think we have a student mentioning about make comment about different kind of reason why Hong Kong's building can last longer. Yeah. Well, anyway, this is a good for you to think about, right? So that the building engineering is long term, I would say. Once you finish building, and then still you need to after certain period of time, they have to do some maintenance for sure. There's no doubt at all. Otherwise, the building can cause some big trouble. So that this is something maybe we should also try to look at this video for you to understand what one of this thing.
Be our boat. Actually, our building does look a bit old, but it's still livable. Does it really need maintenance?
Of course, the building is exposed to the sun and rain over years. Without proper maintenance, accidents can happen anytime. It's just like a time bomb.
Don't be ridiculous. It's scary.
Yes, it is. Here, put on this VR headset.
What is this? Hey, where am I?
Don't worry. I'll take you on a tour about common defects of buildings. Just stand here and watch.
Oh no! The canopy is about to collapse.
This is defective concrete. Rusting steel reinforcement bars or overloading structure causes concrete cracks or even spalling, from which the pedestrians might get hurt.
This external wall is even more worn out than our buildings.
We call it defective external wall. Aging of external wall finishes or abnormal movement of building causes deterioration of external wall finishes. It's not only a matter of appearance. The loss of protection of external wall will speed up the aging of the building.
Horrible. Ew. Why is water seepage so serious here?
There are many causes for water seepage. It doesn't only affect environmental hygiene, but also cause the rusting of the steel reinforcement bars inside the concrete, reducing the structure's weight-bearing capacity.
Doesn't it make the building dangerous?
Exactly, Mr. Chen. Defective drainage system is another common building defect.
A minor problem, right?
Absolutely not. Pipe burst leads to seepage into concrete. These caused the rusting of steel reinforcement bars, and putting the safety of building structure at risk.
Really? I thought pipe burst only affects environmental hygiene. Are those freshwater pipes rusty and leaking? What a waste of water!
Yes, defective pipes also cause failures in the water supply system. It might lead to water supply suspension.
The accumulation of water will cause mosquito breeding. How disgusting!
The defective gas pipes are even more problematic.
I know. It affects gas supply at best and gas explosion at worst.
Also, the defective windows, leaves, and electrical installations or affect residents and public safety. The maintenance of fire safety provisions and fire service installation and equipment is very important as well. In case of fires, the consequences of malfunction of fire safety provisions and fire service installation and equipment will be catastrophic. Keep an eye on any unauthorized building works in the building. UBWs affects the building structure and public safety. The Buildings Department will issue removal orders of UBWs to owners of the Owners Corporation.
There are so many potential risks of a building with poor maintenance. You should be aware.
For more details and handling methods of common buildings defects, please watch other videos.
Okay, so here's give you. I think this video can quickly show you the some past potential failure of some building issue. So that I just upload that the picture of the failure happened yesterday in Professor Chen's this office. Let me show you this picture I took this morning about this the failure of this thing. So it's a real real failure. Here I show you this. Let me see here. This is the office problem failure happened yesterday. So suddenly, this you can see the ceiling fell down, and then so that so here, let me highlight. Here, this is I think this is a aluminum steel frame, and then somehow the fail and then fall down. So so this is something happened yesterday in our USD, our Professor Sherry Chen's office. So let's show you one more. Oh, did you see? How come it can happen? What do you think? What's the comment about this thing? We are working, you study inside the classroom of office. Suddenly, before this can suddenly fall down. What's your comment? What is it? This is something. Unfortunately, it happened. It's real. Happened yesterday in our MAE office inside our academic building. So it's something real issue. It's not something fun, right? But I can see this is something is still happen, right? All the building will have a limited lifetime, and then if you don't do the maintenance and the check the thing, and then it can really cause some big trouble, right? And cause some injury and failure. Okay, so that anyway, so I just show you that something happened yesterday in one student mentioned what Paul Yan Lee is may have smokeless Korean barbecue inside. I don't think the Professor Chen will do some barbecue Korean barbecue in her office. So this is something I think I don't think maybe if you do this kind of thing too often, and then the barbecue in one apartment or office and make some problem. But I don't think this failure is due to this barbecue issue. But anyway, so that we almost run out of time today. So I don't know, do you any question for today's lecture? Oh, I provide you additional help or information for you about COVID-19. So that unfortunately, I do think it's important, useful for me to share with some recent information for this thing. Again, give you remind you about this kind of one page reminder, and then also I try to show you about this something unfortunately from 2015 Nobel Prize winner, the conversation within, so that at least I tell you some issue. So it's originally it's a news from Japanese news, right? Mainichi Shimbun, so that I convert into the English and Chinese. So again, the key thing here is message to you is this kind of low cost drug now for COVID-19 patient, right? Ivermectin was invented by Nobel Prize winner in 2015, Professor Omura. So that actually his this invention really treat a lot of this kind of patient for those kind of parasite. And actually he also do this kind of clinical study about this kind of ivermectin for COVID-19. But unfortunately, there's some big issue. So that those actually this kind of efficacy of this kind of low cost ivermectin is very effective. But unfortunately, because the big pharmaceutical company try to also spend $1 billion to develop this kind of new drug, so that they prevent this kind of low cost ivermectin to be widely used. So that WHO actually they don't recommend this one. But eventually, this is something I tell you that in the following weeks, many weeks, I see more people in Hong Kong will die. So I just let you know that this ivermectin is well-known drug for this kind for 40 years, right, to treat some kind of disease, and then so that this particular one has been proved should be useful. But unfortunately, I don't believe Hong Kong government actually let this kind of ivermectin used in the public hospital. So I just let you know that this is something, provide you more information, and then in case you or you know some people who suffer this kind of very severe this kind of a problem of COVID-19 infection, this kind of low cost drug can save people's life. Okay, hopefully that make sure prevention is the first thing, and then in case you see some people in Hong Kong really suffer about very bad this kind of symptom about COVID-19 infection, I think this low cost one have been widely used in India, in Africa, in some developed country like in Peru and in Brazil. But unfortunately, it's somehow cannot be accepted by some of developed countries, United States, in some Europe. So, but at least provide this information. Okay, that's it.